What's up? Ron here. Today on 3D NerdStop, we're going to print out a calibration cube, then we're going to print out a torture test, and see how well the Robo 3D R1 Plus printer works straight out of the box. Okay, here we are. We're in matter control, and we're going to do a printout of a calibration cube. Now we have a calibration cube over here in Thingiverse. It's just a simple 20 millimeter calibration cube. We'll download this and install it. So let's click download. We'll let it come down, and then we will just bring it up here in matter control. And there we go. As we can see, it's just a simple little cube. Now, for as far as the settings on this goes, we're just going to do this at medium quality, at 0.2 millimeter height, and we're going to do this with 25% infill. Just going to leave it on standard medium settings and see how it comes out. Okay, we'll get the printer heated up and get it going. Okay, so here's our cube. Now, as we can see, this is a 20 by 20 millimeter cube, and everything looks good. The sides are nice and smooth. The top looks good. The bottom, which is a little hard to see, but we'll see if we can see it here, is a little ridgy. Now, I had forgotten to mention in the printing of this, I had made a small adjustment to the Z-axis and actually increased the offset by 0.1 millimeters. I thought the first print we did, the calibration ring, looked like it was a little smashed into the build plate, but apparently not. Apparently, by looking at this piece, it looks like it would have been just fine without doing that. So when I do the next print, I'll just have to remember to adjust it back. So this is the cube. Now let's see how good it is for calibration. Here's some calipers. Let's start with the Z-axis. So the Z-axis is 20.25. Part of that is probably because of the fact that I adjusted the offset. Try the X and the Y. 20.07, and 20.09. That looks acceptable to me. I mean, it's always going to be off by a little bit because the plastic expands and contracts depending on the weather and everything, you know. So, yep, it's just the Z-axis is off. And it's almost within acceptable tolerance. You know, 0.5% is considered to be acceptable tolerance. So, that looks pretty good. So, we will now switch over and do the torture test. Okay, now let's move on to a torture test for the printer. Let's see how good it can do on some more complicated prints than just a cube. First thing we'll do is we'll pull it up in Thingiverse. And this is the torture test we're going to give it. This is a simple one. This is not an overly complicated torture test for it. but I think it'll give us be a good experiment to see how well it works for right now. So we're going to download it, and then we will open it up in Matter Control. And there you go. You can see the torture test. And in this torture test, you can see it has a cube in it, but it has different thickness walls all the way around. It has all these pedestals. It has different size holes and different shapes. It has some overhang stuff, so you can see how well it does overhangs and bridging and things like that. So we can see how it does that. Another thin piece here. So that's what we're going to do. We're going to go underneath our settings, and we're going to turn off support material. We want this to print without support material because I want to see how well it'll do without support material on it. Okay, we're going to still leave it at medium quality at the standard 0.02 mil with the standard 25% infill. So we're not going to change any of those settings. We're going to get the printer heated up, and we're going to get it going. Okay, so here's the torture test. Well, as y'all saw during the video, this little piece fell down, fell off the build plate during the printing process. So that kind of messed up our bridging here, as you can see. As far as that goes, I mean, it did print out this real thin piece out here. As you can see inside here, the overhangs don't look too terribly bad. There's a little bit of stringing up here. It did an okay job printing these circles out. Now this one's supposed to be an octagon, and it's, well, it looks more like a circle, to be honest with you. But it does have a small circle, and they do go up. And it did print all the pedestals. Now there is some stringing between the pedestals, but nothing to complain about. It's not too terribly bad. And as you can see here on the square, on the cube, that it did print the thin-walled sides okay and the thicker-walled sides okay. So it did do that. Now the one big problem I did notice with this is if we turn it around here and you look down here across the bottom, you can see that it started over here, and instead of going straight up, it stepped over and then went straight up. Well, my thought for that is that's of course on the x-axis on the printer, because this is how it was on the printer. So this would be x. And more than likely, there's 3 major reasons this would happen. 1, the stepper motors missed a step. It's not likely I didn't hear the stepper motors miss. I didn't hear them make any weird sounds. And for my CNC router, when it misses steps, that's you usually hear a weird sound in the stepper motors. I did not hear that in this. The other reason is there's a sprocket on the end of the stepper motors that has little teeth indentions in it for the belt to grab a hold of. Now, if that piece is loose, it can miss steps. Or if the belt itself is loose, it could miss steps. So we're going to tighten the belt up and tighten that little sprocket onto the end of the stepper motors. And we're going to do that, and hopefully that'll fix this problem, and we'll reprint this and see how it came out. Okay, as we saw, we had a little problem on that last print, on that torture test. So I was looking into it, and I have decided I want to print out a little belt tensioner to put on there. So we're going to flip over the Thingiverse real quick. And I found a belt tensioner for the Robo 3D R1. So we will download this. And then we will switch back over to Matter Control, and we will bring that up. We're going to open that, and we'll go to Settings and Control. And we're going to print that off real quick. We're just going to leave it again on medium quality at 0.2 millimeters at 25% infill. That should be good enough to put it on there and see if it helps any. Okay? So we'll get the printer heated up again and get it printing. Okay, well here's a little belt tensioner we printed out. Now this little belt tensioner here, as you can see, has a little slot here for the belt to sit in, and it has the same on the other side. And the center is thicker, so it'll make the belt go in here, below that, and then come back out here, which will bend the belt a little bit and add a little tension to it. So we'll throw that on the printer, and then we will get the second torture test printed out and ready to go. All right. Well, we got the belt tensioner printed out and put on the printer. Now let's see if it helped any. We're going to print the torture test out again. As you can see, I brought it up here again. The only thing I'm going to do different this time is I'm going to create a raft for it. By creating a raft, hopefully that'll help keep this bridging piece here from the one end falling over like it did last time. And hopefully we'll get a whole bridge this time by doing that. So we're just going to turn on the raft. We're going to leave support material off and just turn on that raft. So we'll heat the printer up and get her printed.
Everything changes.
Life. Life.
Alright, here's our second torture test. Now, like I said, this time we printed this one on a raft. As you can see, it's on a raft. So, of course, the bridge here, this time, stayed intact. It didn't fall off. And as you can see, it didn't do too bad. It actually did that bridging quite well. There's a little bit of stringing under there, but nothing too terribly bad. The holes on top came out much better this time. The octagon actually kind of looks like an octagon. I don't know how well y'all can actually see that. The rest of the holes look good. The pedestals are all there. Yeah, there's some string in between them, and maybe I can work on some settings to help get rid of that, but it's not really that bad. Now, the cube came out with all of its size printed out nicely. And if you notice, we come over here, we have a nice straight Z-axis now. So the X-axis didn't shift that time. And if you look here, neither did the Y. Everything looks good on the Z and Y axis this time. You go inside here, now the bridging underneath here wasn't quite as good as it was the first time, but it's still acceptable. Now we're on this raft. Now, when I break this thing off this raft, I don't know if this piece is going to survive coming free from the raft, and I don't know how well this will do. But we'll give it a try. Let's see if we can get it off the raft. Ooh, wow. That makes it tough to break free. I have not tried to remove one of these from a raft before. And the raft itself just seems to be breaking out around the edges and leaving everything on the bottom instead of breaking free from the bottom as well. Now this could be because I've let this completely cool down before I'm trying to break it free. I mean, that just seems to be how it's coming free. Does not come free very easily from it. I mean, comparatively. Just like I expected, that piece would not survive being pulled off of the raft. Well, I don't know if that's how it was supposed to break free from the raft. As you can see, if that's the case, it leaves the bottom really rough, which makes me think it's not supposed to stick quite that hard to the raft. I'll need to get a hold of a pair of needle nose pliers and see if I can clean that up any better. But as you can see, just using my fingers, it really doesn't want to let go of the raft on this print. I'll have to look into that. I don't know why that's the case, or if that's just the way it's supposed to look. I would think this was supposed, the raft, the very bottom layer was supposed to come off all the way across. And if it doesn't, well, I mean, for this it's not a big deal, but for some of my other prints I would do, I may not like that. So we'll have to see how that does on some other prints. So, but there you go. Now you have it. There's the second torture test. They came out good. Thank you for watching. If you like what you saw, please like and subscribe. Please leave a comment down below. I'd love to hear from you. Until next time, have a great day. What's up? We're on here. Today on 3D NerdStop, we're going to print out a calibration cube, and then we're going to print out a torture test. We're going to